Hi, sorry, spider crawled on my bed and I got really scared, so had to kill that. Continuing on, next proof is prove d over dx of sine x equals cosine x. Like that. So what you want to start off with is we are given, well, first of all, we're given the formula that the sine addition formula, that sine of a plus b equals sine a cosine b plus cosine a times sine b. So you want to start off with doing the derivative, and I like to do the one using h. So I do limit of h approaches 0 equals sine of x plus h minus sine x over h. And then you can just use the formula and just like that. So now I can just use the formula equals limit as h approaches 0 of sine of x times cosine h, so just plug it in, plus cosine x sine h minus sine x. I don't know if you can read that last one, but the last one is sine x. So there we go. And then you just simplify. Limit of h approaches 0 of sine x times cosine x minus 1, cosine h minus 1 over h plus cosine x sine h over h. So I just separate them because that made it a little simpler. And then you have, if you look, because you want to get this flower, I think it's called, this flower right here, which is 0. So that would be 0. So that whole term is x off. So then it's just cosine x, because cosine x. So that's the answer, and that's the proof. Next proof is tan x equals secant squared x. And this one's not that hard either, because we know that sine x is over cosine x is equal to tan x. So that. And then again, I think you just do the quotient rule. So all over cosine x squared, square the bottom, and do low d high. So cosine x times cosine x squared, minus derivative of the bottoms, negative sine x, times sine x. So then you just simplify again, which would be cosine x squared plus sine x squared. And I like to split the bottoms again, so over cosine x times 1 over cosine x. Oh, cosine x squared. Because, oh, this is squared, so it was actually over cosine x squared. And so, yeah, this is over cosine x squared. And, never mind, I'm not splitting it. Okay, so I simplified it right there, simplified. And then you just, well, cosine x squared plus sine x squared, we know is equals 1, based on those functions that we learned last year. So then it just simplifies to 1 over cosine x, and 1 over cosine x squared, 1 over cosine x squared because of the derivative, and 1 over cosine x squared equals secant squared x. So there we go. Okay, next problem. Next problem is still again a proof. More proofs, yay. dy dx, or no, sorry, d over dx of x to the n. This is x to the n1 of nx times n minus 1. So this one's quite annoying, but you just do limit of h approaches 0 of, so this one, since if you multiply it out, keep on doing the derivative, it's like a really repetitive derivative. And you'll keep on getting n times x to the n minus 1, x minus 2. So this is a factorial. So we do that pyramid, yeah, we do that weird, or not a factorial, it's like the weird pyramid thing. So I don't remember what it's called, but it just looks like this, x to the n minus 1 plus n1 x to n minus 2 minus 1. It's just really repetitive. Times h. Oh yeah, it's the pyramid thing. So you just keep on adding these functions, because if you remember the pyramid, it's like the outsides are just x squared. Like let's say it's x to the third, it's just outsides are x to the third. Then you do, it's the two functions thing. And then so yeah, what you would do next is, since we know that this is the way it works, you would just explain that you plug in h for all of them, and then because the middle functions are going to have h in them, but the outside functions won't, and because those ones are like binomial, and then you would just, because they're all over h, you can just cross off the h, and n to the x minus 1 is left. So that's just the answer. So it's because of the pyramid with the numbers that you're supposed to know. Then you do the proof of f of x. So the next question is f of x plus g of x. So this one looks like that, and what you want to do is do the same thing. Do h, limit as h approaches 0. F of x plus h plus g of x plus h minus f of x plus g of x all over h, like so. Then you want to do, you want to add the function. Oh, actually no, this one doesn't require functions. You just want to split up everything together. So g of x plus h plus g of x over h minus f of x, well, plus f of x plus h minus f of x over h. And and because, I made a mistake, because the negative is supposed to be spread out, it's minus g of x. So you just do that. And then we know these are both definition of the derivative, so g prime of x plus f prime of x. Okay. So that's the answer to that one. Hold on, more paper. Okay. Now, the next problem is it just says product rule. So you just do limit as h approaches 0 of f of x plus h So you would just do multiplying of g of x plus h times f of x plus h minus f of x times g of x over h. That's what it should look like, what your starting point should look like. Then you would do, you want to add the factor, you want to be able to factor out g of x plus h from both sides. Well, from one side and then f of x from the other side. So you want to add these two variables in. So you want to, because you have to make them equal to 0. You have to do minus 1 and plus 1. So g of x plus h times f of x plus g of x plus h times f of x. And then minus f of x, g of x, and f of x plus h times g of x all over h. Really hope you can read that. Sorry if this is, you can't see this. Okay, there. So then what you want to do, next step is just factor. Learned this before, and it's the same thing. So factor out g of x plus h from the first one. And then factor out f of x from the second one. Like that. Like that. Okay. And now you have the definition of a derivative. So just split up the whole thing, limit as h approaches 0 of g of x plus h times f prime. Well, because I don't want to write it out. And then f of x times g prime. And, so, and then you just want to, but when you do it for the test, write out f of x plus h minus f of x over h. I just did it to save room. So you have to write it out. You can't write f prime with the limit. So now that we're going to cross out the limit and plug in h for 0, you will literally get g of x prime, literally just get exactly what the product rule is, which is f of x prime of x. Like that. So yeah, there's the product rule.